This video, we're going to show a powerful fact. Suppose N and M are both normal subgroups of G such that their intersection is E. That is, N-intercept N only contains the identity element of G. Then N times M is equal to M times N for any combination of N and N and little m and capital M. Normally, what we have is that N times N is M times a different N, or M times N is a different M times the same N. It's unusual to find this. In fact, you always find that only if N intersect M is the empty set. Hence the fact. If you like watching mathematical proofs, like hopefully the one I'm about to give, subscribe to my channel. Okay, so let's get right into this proof. We know that Mn is E times Nm, and we can think of E as M times N inverse times Nm. But now, this here is the same as M times N inverse N times M. But by definition of N, capital N being normal, this here is an N. That is, it equals to or M times N prime. This is some other element of N. Okay, so we have pretty much what I stated at the beginning of this video. NM is M times a different N. Now I want to show that if the intersection is just the identity element, or just contains the identity element, then this element here is in fact N. Okay, so now, like I said, we know that NM is M times N inverse. Well, this is NM times E times Mn prime. Okay, now this is Nm, and we're going to replace their identity element with N prime times N prime inverse times Mn prime. And we're going to use the associative law. This is N prime times N prime inverse times M times not M prime but N prime. Okay, now this here is in capital M. That is, it equals to, say, M prime. Okay, so now we have that this is equal to N prime times this, which is M prime. Now, let's just write this down. Bringing this to the other side, we have that M prime inverse times N is equal to M prime, bringing this over, times M inverse. But now, this here is an M, and this here is an N. That implies that N prime inverse times N, which is equal to M prime N inverse, is in N intersect M. But that implies that, for example, N prime inverse times N is E, because that's only E. This is E, and that's E. In particular, that's E. Bringing this to the other side, that implies that N is equal to N prime. But that's what I wanted to show. Recopying this line down and calling that N, that implies that NM is M times N prime, which is N. And that is what we wanted to show. I did show it. This proof is complete. If you like watching mathematical proofs like this one, subscribe to my channel, because this is what we do here. We prove mathematical theorems, we prove mathematical lemmas, corollaries, we do proofs by induction, proofs by contradiction, contrapositive proofs. You see it all here. No matter which video you click on, it's going to be a mathematical proof. Again, if you like watching math proofs, subscribe to my channel. If you loved or hated this video, please click the like or the hate button. Please leave a comment, pro or con, doesn't matter to me. See you guys in the next video. Never forget, please keep watching and learning.